Algebra 2, Chapter 6.2, Exercise 1 through 13. I'll go over these odd-numbered problems in this set. Use a graph calculator to graph the polynomial function, then use the graph to determine the function's domain, range, and behavior. Use interval notation for the domain and range. And prior to starting this video lesson, I went ahead and entered in the function editor function y equals x to 7 power graph. And here we have your starting low as you go to the right, increasing all the way and smash flat up against the x-axis where x equals 0. So, anyway. So our domain for this and also for all polynomial functions is going to be greater than negative infinity, less than infinity. The range, I'm just going to put R colon, is likewise going to be greater than negative infinity, less than infinity. And next it says end behavior. And our end behavior is going to be as x is approaching infinity. I guess we'll use positive infinity. F of x is approaching the same thing, positive infinity. As x is approaching negative infinity, f of x is approaching negative infinity. So that'll be it. That's problem number 1. Next, problem 3. With f(x) equals x to the 10th power. So we go to our calculator, to our function editor, and we're going to use the same thing, except in place of 7, we'll put 10, graph that, and we have a U shape here. Touching the x-axis at x equals 0, and smash up flat against that x-axis. But let's go ahead and make the subdomain for this and all polynomial functions is going to be greater than negative 10, less than 50. And looking back at our calculator for range, you see that we touch, but do not cross the x-axis. So our range for this is going to be greater than or equal to 0 to less than infinity. And finally, our end behavior, as x is approaching infinity, or positive infinity, f of x is approaching also infinity. As x is approaching negative infinity, f of x is approaching negative infinity? No. We are approaching infinity as x increases toward infinity and as x decreases towards negative infinity. So we start high, end high. That is an even function. So this is problem 3. Boxton is correct. Next, 5. Use graph calculator to graph the function. Then use the graph to determine the number of turning points, the number and type, global or local, but not global. And these choices are going to be global or local but not global of any maximum or minimum values. So let's go put this in our function editor. X plus 1, x plus 3, Clear this out. X, 20x plus 1, close, 20x plus 3. I think this will work. If we graph this, there we go. That worked pretty well. So we start low and then high, and in between starting low and then high, we have two turning points. And these are both local. There's a local maximum and a local minimum. Let's go ahead and articulate that here. We graphed determine, so we say two turning points. And the number is high, so we have and these are all local. We do not have global for 5 at all because we see there's no global maximum or nor there's a global minimum. So we will say we have a local maximum, so one local maximum, abbreviate maximum, and we also have one local minimum. And so, and I guess that's going to be it. Okay, let's go on to the next algebra problem, which is 7. We have here negative x times 20x minus 2 squared. Let's go ahead and put this in the calculator. Negative x times 20x minus 2 squared. And so we graph this function. And we have also two turning points. Down here about where x is between 0 and 1. Over here about where x is 2. So we have also here two turning points. We have no absolute or global. That's another thing. It says global in the book, but global is the same as absolute. So two turning points, and we have one local maximum. And that's going to be about where x equals 2. And we have one local minimum. And so that would be 7. Next on our problem, 9. Here we are, sketch the graph. What's the graph of the following function? Of course, yeah, anyway. If English is not a high priority here. Okay. So we have our zeros, or x-intercepts. We can find these by setting each factor equal to 0. We have x is equal to 0, because we set x squared equals 0. Now we have x equals 0. We have x minus 2 is equal to 0. So if we add 2 to both sides here, we have x is equal to 2. We have an x-intercept at 0, x equals 0, and at x equals 2. And this one here presumes that you don't have graph calculator in hand. So let's go ahead and distribute, see what this looks like instead of we have x squared what I'm going to do for that is write it over to the right. So I'm going to put f of x equals x squared times 20x minus 2. And if we distribute here, we have f of x is equal to x cubed minus 2x squared. So that's what that looks like. And our leading term is going to be this one, x cubed, which means we're going to start low and end high. And this one here, we have x squared equals 0. So we have x equals 0 and x equals 0. And so we're starting low, and we're coming up here, and this one has a multiplicity of 2, and then we're coming down here like that. So that's what this looks like. And we have the essence here. We'll go over this in a lot more detail next year in pre-calculus. Those of you who take this fall course, pre-calculus. So this is very much like, it's kind of the same thing we have here, isn't it? Well, not exactly. I think that's it. It's negative. So it's a lot similar to number 7. It's 111. We have negative 20x plus 1 to 20x minus 2 to 20x minus 3. And to find our standard form, we can multiply all these together. I'm going to do these one at a time. I'm going to multiply these. We have a negative sign out front. So make an equal sign here. I'm going to multiply these first two together here. First two factors, we have x plus 1. And we have x minus 2. So just multiply together x squared, x, negative 2x, and negative 2 times 1 is negative 2. And combining, we have negative 2 plus x. So we have x squared minus x minus 2. And we multiply that by our remaining factor, x minus 3. So we'll create another box for this x minus 3. This. We'll put x minus 3. So we have x cubed, and then x times negative x squared, x times negative 2x. We have negative 3 times x squared, we have negative 3 x squared. Negative 3 times negative x is going to be positive 3x. Negative 3 times negative 2 is going to be 6. So we have x cubed, and then we have negative 3x squared minus x squared, so minus 4x squared. And we have 3x minus 2x, that's going to be plus x plus 6. And the last thing we have out in front of this negative sign, we put this negative sign out front. So we're going to have negative x cubed and minus negative 4x squared is going to be plus 4x squared. And then we have minus x minus 6. We'll write this up here as negative x cubed plus 4x squared and minus x minus 6. So our leading term here is going to be negative x cubed, which means we're going to start high and end low. So a negative characteristic. And so each one of these factors produces a 0. So we have x plus 1 is equal to 0. So we subtract 1, x is going to be equal to negative 1. We have x minus 2 is equal to 0. We add 2 to both sides there. we have x is equal to 2. And then finally, we have x minus 3 is equal to 0. Add 3 to both sides of the equation. We got x is equal to 3. So we mark these at x equals -1, at x equals 2, and at x equals 3. And we know we are starting high. So we're going to come like this. The red one here. Starting high. Come down here. Touch and cross the okay. Go up here. So that's going to be it. Okay, let's go on to, well, I meant to do number 11, but I did number 10. So I'll just let this one here. I'm just going to work on the first one, kind of get you started on this. So here we're going to have x times x squared. So that's going to be x times x squared times x. And so we're going to have x to the 4th power. If you just multiply everything together, I think for this one, you're going to start high and end high. Okay, next on the problem, which is 13, we have this template shows how to create a box from a square sheet of cardboard inside one. And so I'll give them a drawing here. And it says write a volume function for the box in terms of x only. And here we have, across the top, we have 2 inches for this little distance, and x, y, and 36 inches is the total. So what we have here is the width of the box is going to be, well, our height of the box is horizontal strips. Okay, so these are going to be little squares at the edge. What corners we cut out of here? Looks like we have this here. These are squares of x over 2. So we have 36 inches is equal to 2 plus x plus y plus x plus y. So we have 2x plus 2y. And what we have here is we're going to have x for that. So let's go ahead and solve for y. Subtract 2. So 34 equals 2x plus 2y. If we divide everything by 2, we have 17 equals x plus y. So y is equal to 17 minus x. So this is going to be one of our sides. Also, we have this side over here to the right, which would be 36 minus x over 2 times 2. And 2 over 2 cancel. So we get 36 minus x. And then the last side we're going to have is this height here, x. So we have 17 minus x, 36 minus x, and we have x. So that's going to be it. So we have the function is going to be volume equals x times 20x minus 17 times 20x minus 36. So that's going to be one of our answers here. It's the volume function to the nearest tenth. Find the dimension of the box with the maximum volume. Let's go here and enter this in the calculator. We have x times quantity 17 minus x times quantity 36 minus x. And we're going to find between 0 and 17, that's going to be our max value of x. We graph this function. And let's go ahead and set our window because we know we're going to need to go from 0 to 17 possibly. So I'm going to change this to 20. And then if we graph this function, this is what we're going to get. You don't see a whole lot here. We're going to need to find a maximum way up here someplace. I'm going to go experiment the window. And I'm going to put my y max up here to 2,500. I'm going to go by 100. Now, I will tell you that I already knew this. I kind of experimented already a little bit. So here, way up here at the top, that's going to be our maximum volume. And then as far as finding that maximum, we could trace to find the maximum. But the way to really do this is go to second trace, which is calc, and we go down here to 4, which is our maximum. Press that, and then we have a question mark here, left bound. So we're going to arrow over to the left of our maximum and press enter. Now it says right bound. So we arrow over to the right of the maximum and press enter. So guess one last time. And so our x value is going to be 7.2, let's say 7.27 to the 100th place. So 7.27 x is equal to 7.27. And hang on a second, I forgot to mention something. And what are we in here? Inches, right? So that's one dimension. But what is that maximum volume? The maximum volume is going to be 2,032 cubic inches. Two thousand 32 cubic inches. Okay. So we have x equals is 7.27 inches. Also, we have x. We're going to have 17 minus x. That's going to be one dimension. And we're going to have 36 minus x. So let's go ahead and do that. We're going to have get out of here. 17 minus 7.27. We're going to have 36. That doesn't look right. 36 minus 7.27. It has to be a dimension of box, yeah. That'll be right. Here are the dimensions. 9.73, 28.73. So here we have our volume equation, volume function. Here we have our dimensions of our box. So really, that's it. I hope this can help you. Good luck, and thanks for viewing.